So we already know that to transform an x value to a z value, we use the formula that z is equal to x minus mu divided by sigma. And that formula came from lesson 15 right here, where we had these x values, like for instance, 22 and 52. Those are x values, those are data values. I want to turn them into standard scores so that I can look up their probabilities and answer them. Now in this lesson, we are going to be starting with standard scores and going backwards to get x values. So the formula that we will use here is actually the same formula, because if z is equal to x minus mu divided by sigma, this time I just want to solve for x. So doing some quick algebra, I'm going to multiply both sides of this equation by sigma so that that cancels, which gives me that sigma times z is equal to x minus mu. I'm just going to rewrite that equation up here so I have some more space to work. I'm trying to solve for x. So I'm going to add mu to both sides of this equation. So I can see that x is equal to mu plus sigma z. Mu plus sigma times z. So if I have the z score and I want the x score, I will use the formula that x is equal to mu plus sigma z, which is the exact same formula as that. It's just different variations of it depending on what we're starting with and what we want. If this algebra in here, it does not make 100% sense to you, that's okay. This is not an algebra course. This is a statistics course. So you won't be expected to do algebra or anything like that. You can just write down this formula and use that formula. I just wanted to show you all where that was coming from. So now that we have seen that formula, let's look at example 5. So we have a vet who is recording the weights of his cats treated at his clinic. The weights are normally distributed. All that tells us is that I can draw a bell curve when I'm doing these problems. It means that my data is symmetric. With a mean of 9 pounds, let's go ahead and start jotting down some information. A mean of 9 pounds. That tells me that mu is 9. And a standard deviation of 2 pounds. That tells me that sigma is 2. We're asked to find the weights. We want to find the actual data. We want the x values that correspond to z scores, and we want to interpret the results. So first we're going to find all the x values, and then we'll interpret them all together. I'm going to use a different color for all 3 of these. Starting off, z being equal to 1.96. Just drawing a little bell curve here. 1.96 is going to be greater than 0, so here's the z-score of 1.96. I want to know what is the equivalent of that as an x-score, but we're just going to use the formula that x is equal to mu plus sigma z. We know mu, it was given to us as 9. We know sigma, it was given to us as 2. And we know z, it was given to us as 1.96. And when we actually do these calculations, what we get, scrolling to my answer sheet, is 12.92 pounds. I'm going to draw another bell curve for the second example, where now we have a negative z-score of negative 0.44. So this time when I draw that bell curve, sorry, I know I have a lot going on right here. This time when I draw that bell curve for negative 0.44, I will be to the left of 0 just a little bit. And we're interested in what is that corresponding x value. Well, we know the formula that x is equal to mu plus sigma z, and we're just going to go ahead and plug in. Mu is 9, sigma is still 2, but this time z is negative 0.44. And this gives us 8.12 pounds. So please do check these in the calculator behind me. I have made mistakes before, but I'm pretty sure I know these are right. I didn't make a mistake on these. But still, you should be putting these into your calculator and working along with me. In the last example, we have that z is 0. Hopefully, that last question that was in the presentation, you know that that's perfectly in the middle, right in the middle, 50% of the data on the left, 50% of the data on the right. That represents the 50th percentile. That is the mean of the data. That is the median of the data. That is the mode of the data. All those things are true when we're working with a normal distribution. Let's go calculate. So we have the z-score. We want to know what the x-score is. Let's go calculate that using the fact that the x is equal to mu plus sigma z. We know mu is 9, we know sigma is 2, and 0 is our z-score here. And so we get that we have 9 pounds is the x value that corresponds to that. So now let's do some interpretations of this. So what I'm going to do off to the side here is I'm going to draw a larger bell curve just so I can have some space to write in it. What we do know, and I'm gonna call, I'll label this first line here, I'll say that these are my z-scores, and then this second line here, I'll say that these are my x-scores. So what we saw in red is that when z was 1.96, x was 12.92, and that's in pounds. So these x's are in pounds. It's the weight in pounds. What we saw in green is that when z was negative, that actually might be a little bit too far to the left, but what we saw in the second part was that when z was negative 0.44, the weight in pounds was 8.12 pounds. And then what we saw at the end is that when we were right in the middle and z was 0, so right smack dab in the middle, when z was 0, the weight was 9 pounds. So our interpretation of that, we can see that 12.92 is to the right of the mean, is larger, is to the right of the mean. It's larger than the mean. We can also see that 8.12, which is what we have there in green, is to the left of the mean. And then finally, we can see that 9 is the mean. And on all these interpretations, these are not great interpretations, you all, until I add some units in. 9 pounds is to the right of the mean. 8.12 pounds is to the right of the mean. And 9 pounds is to the right of the mean. Remember, what we're talking about in the context here is the weight of all these cats that are at the vet.